Okay. You still can't hear me, Ainsley? Can anyone hear me?
Yeah.
Oh, she can't hear me. Huh.
How's life?
Pretty good. How about you?
Eh, finally, Saturday.
I know, right? You guys made me get out of bed early.
What?
You guys made me get out of bed
I
early.
like can't hear
Sorry.
them. I can't hear either of you guys.
You,
This so weird. Can you guys hear each other?
yes, we can hear each
Yeah, we're having a nice
Oh
conversation.
my bar. Don't tell me. Okay, talk now.
Can I hear? Okay, wait. I can hear you. Can you hear me?
Yeah.
Okay.
My speakers were off. I am so out of it. My goodness. Okay. So Sergey did the Google last time. He did it really good. So maybe we'll have him do that while we tell him what to do. Again.
few seconds, okay? Few.
Few seconds. Okay.
Yeah, just I need to plug additional power to my laptop. Few.
Okay. Um.
Ready?
Okay. Are you fine with doing the Google Earth thing again?
Yeah, just let me open assignment.
Okay. And I just pasted everything that we're supposed to do on the Google Doc too. So.
Okay. You know what? I messed up with my initial post on Wednesday. So I posted instead of lesson 8, I posted to lesson 9. And just like 1 hour ago, I realized that I don't have my initial post for this week. I just finished it like few minutes ago.
I don't think it's due until Saturday, so I think you'll be fine.
Yeah, I know, but still, I didn't have anything for this week.
Yeah. No, I think the links were broken because when I
Which
went to
links?
the post, well, at least for the annotated bibliography, I went to like post my initial post and it went to lesson 2's annotated bibliography. So I had to go under quizzes. No, I had to go under discussions and like actually find the one I was supposed to post it on.
Okay.
It was weird.
No. Dumb dog. No, you're not.
Okay. Mariana Strange and Into the Sea of Japan activity requires a Google Earth file.
So I guess we're just
Okay.
looking at the earthquakes in that specific stuff.
Okay. Should we use the same file he posted at the beginning of this week?
Yeah.
Okay.
Yeah, that's probably smart.
I'm not alive. I don't know what you guys are talking about at the moment.
Yeah, so you can open chat window in our meeting right now. I posted this assignment. It says this activity requires a Google Earth file in the first paragraph. So we need to plot the depth of the earthquakes against the distance along the surface. And then the size of the earthquakes as well. Huh?
I have
Yeah,
no clue what that means, so we'll just go with
okay.
So plot the depth of the earthquake. What? Okay, Sergey, are your children trying to bust in?
Yeah.
I hear that. See, I have a dog that's with me, and oh my gosh, and you have kids trying to bust in. My kids are locked in their room playing on their iPads. This is great. Ainsley, don't have kids. Get dogs. Better yet, cats. Do cats.
Yeah, they took their tablets, but I have a little one who's trying to get in without the tablet. Okay. Yeah, probably. Okay, let me call my wife and ask for help.
Yeah, they said multiply and replenish the earth. They're really not. Oh my gosh, look at my hair.
I know, that's what I was doing this morning. I was like,
I did not. I did not just get out of bed. Wait, no, yes, I did. I clean on Friday nights. I clean till like 1 or 2 in the morning. So I do a lot of trade. Yeah, I do a lot of trade work. So like, getting your hair done is expensive, and I kind of like to get my hair done. So like, I clean for my hair lady at her salon. Well, I can't do that till all the clients are gone, and yeah. And then my kids like to play soccer, so I do trade work for the local soccer coach. So yeah, Friday nights are rough.
Yeah. Well, if you ever need us to move times around and stuff, I mean, you guys have been so flexible with me. I'll try my best to work around your schedules too. So.
Just bear with the fact that I might sound like an idiot or look like a bedhead. So.
No judgment. Okay. Okay, so looks like they got the Google Earth thing pulled up.
I'm just trying to figure out what I need to do with this. Okay, Maria.
So
are we? Sorry.
No, go, Mary.
Are we basically comparing the depth of each earthquake against the length of the Marianas Trench? Okay, don't laugh.
I just like it's like foreign language for me.
I don't understand what we're supposed to be doing. Plot.
Yeah, the same thing. Okay, I'm trying to open this file.
Against
is it just
did I open it?
Is it just like the depth of the earthquake and how far the earthquake traveled, or is it like against the trench itself? That's what I'm wondering. I'm wondering if it's.
I was thinking volcano.
So guys, I found a good one. Okay, it's a good work on the plotting out there.
That's definitely not Japan.
Oh, no.
Did you see anything like any feature which shows us actual distance of earthquake in this Earth Pro stuff? I saw only like points where it like occurred. previously, and that's it. I didn't see like distance.
Okay.
Color coding says that it was in
Color
depth of like orange.
magnitude.
Yeah, you see, on this on the left side,
Is
it
the
says like
size?
orange from. Yeah, like what is this?
I think maybe the size is the depth. The color is the magnitude. So if it's like yellow, it's not that high of a magnitude, but it's like big. It was like really like it was a big depth.
Oh, we have magnitude and depth. Okay.
Yeah.
What
So it's
about
all in
this?
the same.
I have found USSAG website. It shows most current stuff in the whole world. Actually, I use it for my journal. I can retrieve it from there. So I will share this link with you in our meeting chat window. It's over there. You see?
Mm-hmm.
Yeah. So go there, and we have. There's a gear sign in the upper right corner, and you can choose different stuff. Even though we can choose locations, right? Like 30 days significant worldwide. Well, I don't know. Yeah, why not? And Japan Sea.
Yeah, so I think like if you just plug in the Mariana Trench into the search,
Okay.
it'll
Yeah.
there.
Yeah, I will try. I will try.
Zoom out, it should show us the earthquake.
Okay.
Oh wow. Oh.
Yeah, beautiful, right? Actually, I saw this stuff in our textbook. This place.
Yeah. I don't see any earthquakes.
Yeah, let me play with this stuff. Now you can see
Oh,
it.
there we go. Yeah. Cool. Purple is pretty big, right?
Purple one? Yeah, the red one. It's over
red
here. Can you see my mouse?
Yeah, I can see the red one. Yeah. Are there any yellow ones?
Yellow? Yeah, it's over there.
There's a couple, yeah. So there's almost the whole range of earthquakes,
Different.
which is crazy.
And the question is what? Okay, into the Sea of Japan. Plotting the earthquake would fall along side across the map.
But look at it's very interesting to see if you as you're zoomed out right there, how like look at the earthquake pattern. It follows that whole, if I'm seeing this right, does that look like an entire plate or like different fault lines? Do you see what I'm seeing? Yeah.
This lines?
Yeah.
And
All the
what about?
earthquakes are gathered around that.
Yeah, so that's the earth is splitting because that's what's causing the trench, right?
I can actually open an additional file. It should be somewhere here. Borders. No. Tectonic plates, yeah. So now we can see tectonic plates in addition to our earthquakes.
Look at that.
So Philippine plate, and then Pacific plate over here, and then Australian plate. What about this little stuff? What is it called? Okay, we need to find what is it called? Sea of Japan.
So I think that's just where the trench is. It's the Sea of Japan.
Over here.
The pyre?
Oh.
So that's the trench, though. That's the fault line that's going all the way up, and then right next to it.
What? Sorry.
That right yellow line is going from trench
Which one?
up to the Sea of Japan. That one.
This one?
Yeah. That's continuous with the trench, isn't it? Down below.
Yeah.
Okay, so we found these places, right? What is next? Plot the depth of earthquakes against the distance along the surface.
I know the size of the earthquakes as well as what trend.
Oh, maybe we can identify like depth. Sorry, maybe we can identify depth of each earthquake along this. What is it called? Reach. Somewhere here, probably.
Yeah, I think that's what it's talking about as you get farther towards maybe the Sea of Japan. The magnitudes and the depths change.
So what do you think if we will take only, oh no, sorry. Kind of this hey. Hey. How does it work?
I'm wondering if we can just take a screenshot of it and put it in the document, because it just says plot the depth, and so we already have the scale on the side and them in the picture. So I think we can just take a screenshot of it and put it in there. Do you want that?
Yeah. So with a legend, right?
Yeah, with the legend. Yeah.
Okay.
So even like right there is fine. Yeah.
Okay, let me. I cannot get rid of this stuff so that we can read earthquake legend.
Oh.
Yeah. So a hot plate here, Philippine plate here, and we have what is it called? Pacific plate here.
Mm-hmm.
Okay, Philippine, Hots, Pacific. Okay, I will turn off.
Well, it's really nice because the French kind of shows us the plate boundaries. So.
Okay, I will do my best in a few seconds. So first of all, I will take care about this guy. Then I will turn on back plates. Now I'm taking screenshot. Going this, like this. A few earthquakes, group activity. Okay. And we have a link for Google Docs, right? Okay.
Mm-hmm.
So it's asking us what trends do we notice in the data? And I mean, it kind of looks like it that the closer the earthquake is to the trench, the bigger the magnitude.
Uh-huh. Yeah, we actually can. Yeah, that one. Yeah. A few seconds. I'll be back.
How can we find out the depth of the trench at certain locations? Because I wonder if there's any correlation between like the purple and the red earthquake being at a point in the trench where it's deepest.
Oh,
Or
we can draw lines. We can
lower.
draw lines, and it will show us actual depth of this place. I will do this in a few seconds. I will show you on Google Earth.
Mhm. I think I can mute myself.
Okay, so I think I can answer this one. It says, what would you expect to see if you went further inland? And the depth of the earthquakes would decrease on land, right? Because they would be traveling, they'd be traveling from the ocean, from the depths to the surface.
We have what is it called? Subduction zone, right?
Mm.
So it goes underneath of this huge plate. That's why it's deeper here. And then, yeah.
But then it has to travel to the surface. Right.
Yeah, so remember we used this tool, what is it called? Lines. So we can actually create a line and depth, right? D-E-P-T-H.
Okay.
Depth. And then draw. Oh, sorry. One more time. Okay. So I will put it like this, or maybe a little bit shorter. For example, let's take this corner. And okay, and it shows somewhere. Where's my layer? Yeah, it's over. Now we can see elevation profile.
Oh, wow.
Yeah, so can you see it?
Yeah. So go back
so
up
it's
to where the blue circles are.
Huh?
Go back up to the area where the blue is.
It's kind of
right in there.
so. I mean, I need to create additional line which goes like over this blue circle. This one goes. I was trying to find the depth of this corner here.
Okay.
Yeah, that's why I put it here. Yeah, and like usually.
What if you did like a cross section of that? Like do
What?
another line going perpendicular to that line.
How? Like this over here or where?
Yeah. Yeah.
Right over this edge?
Yeah, right over. Well, do right over the
Almost.
dots. Like in between the
This
edge
dots?
of the island. Yeah.
Okay, I will try.
Because I'm assuming that edge is the top of the trench. So that wouldn't be
Like
as
this?
deep as the bottom of the trench. Yeah.
Okay. Do you want to take screenshots of this information here?
Yeah.
Okay, a few seconds. So first of all, I wanna take. So I can highlight. Distance 1. So we have distance here, 114 miles, and the depth. But I'm sorry. Oh, gosh. Yeah, depth about like 225 miles. Distance. Okay, never mind. Screenshot. Okay, and then no, it's the same. Oh, that too. Okay. So I'm not sure about this guy. It shows nothing.
Oh, the big one.
Yeah, so we actually don't have any graphs here.
That might show the trends though over a longer distance because we can't really do that line very well over the whole thing because it curves and the line is straight.
Okay. Yeah, there's no information here. I don't know why. Should be. Let me restart this. Yeah, I don't know. It doesn't work. Can you hear me?
Yeah.
Yeah. So it shows only distance, and that's it. Maybe I choose wrong stuff. Description. All to view measurements. Okay.
So, okay, I'm just trying to get this like straight in my head. So, at like a subduction zone, the depth of the earthquake should be greater because one plate's going underneath the other one, whereas like, if it was like two plates like separating, it wouldn't be as deep. Does that make sense?
I think so.
We have a huge one here because of Philippine. What? Yeah, so Philippine plate goes under the Pacific, right? Am I right?
I thought that was backwards. Doesn't the Philippines plate go over the Pacific plate? I don't know.
Divergent here. So it goes under Pacific. Am I right?
Okay.
And just this guy overlapping Philippine plate, I think. Here we have another situation when Pacific plate goes under this whole thing.
Okay.
Am I right?
That is craziness.
Okay. So what is next?
Okay. It says, what trends do you notice in the data? Oops.
Trends.
Are we answering these? Okay, maybe stuff. How do you explain?
You know what?
So, like, when they're right at that boundary where the plate's gonna start going underneath the other one,
Yeah.
that's closer to the surface, right? So it makes sense that the depth of those earthquakes wouldn't be as great as if it was happening like right here, like underneath the earth, right?
Or like further back from
if we look, because if we look right along the yellow line where that boundary is, like right here, it's like orange and yellow, and those are like the least of them. But if we go a little bit further away from the line, like over here, that's when we get our reds, our greens, our blues, our purples.
Purple, yeah. And it seems to be, I would be interested to see if, I can't see it now. So there's a purple one down here where the Philippines plate meets, oh yeah, right there, right there. That one. And then wasn't there another one up here closer to Japan. Yeah. I think I would have to say you're right, because if you look at the distortion of the land or the plates, it's right about where that those ridges start to happen. Um, that those most powerful earthquakes, the deepest ones, are happening. And that's right, as you're saying, like, that land that's
Yeah, that purple one is right on the edge of Japan.
right. So this one, hold on just a second though. So this plate is the Philippines plate, right? This one that's right here on the left of our screen, kind of in this triangle of yellow. Yeah, Philippine plate. So this plate is going under the Pacific plate, right?
So what is the reason we have divergent line here and divergent line here on the kind of opposite sides of this plate? So inside of Philippine plate we have divergent here, and the divergent on the other side over here from, I don't know what is it called, this plate.
I don't know.
Yeah, just trying to see. Divergent.
So that means that plate is going under, right?
Here or here?
Both those red lines. I'm not alive.
I see.
Maybe I should just give up.
Okay, so divergent tonic. Now it says, let me show you.
I guess what I'm trying to do is understand that divergent thing so that I can make sense of the stronger earthquakes. Maybe Ainsley, explain again what you were saying, because it's right there by those divergent lines that we see those like purple earthquakes.
Mm.
Are you seeing what I'm saying, or did I even make sense? If I don't, it's totally fine.
We're seeing the what kind of earthquakes?
So we were talking about, so like right here, I can't even highlight anything so you can see what I'm saying.
So like the red is the divergent boundary, and then the yellow is the convergent plate boundary. So which one of those?
The red.
But we have both.
Boundary. Yes. Hold on though. There's there's a purple earthquake right there, just beyond the Philippines divergent line. Do you see that one? So there's the divergent line, and then there's the purple earthquake right here, just like northeast of that line. Right.
The bottom one or the top divergent?
Bottom.
One. I'm not seeing the purple. I see a red and a blue.
So look like north, like, okay.
Oh, yeah. Now I see it.
And then pretty much the same thing on that red divergent line that's on the plate above the Philippines right there. Just like below. I wish I could highlight it so you can see what I'm saying.
Yeah. So what I'm wondering is, because the dot is the magnitude. So that's how big an earthquake it was, right? And then the size of the dot is the depth.
Depth.
And we're trying to focus on the depth.
Okay.
So what I'm seeing is if you look at the
Now I'm not confused.
from the bottom one. Go up from the bottom divergent plate following the yellow one, and there's like a three-way intersection right by Japan, and there's an orange dot that looks like it's like in the middle of the trench, and that dot looks a lot bigger than like the purple dot that's right on top of Japan.
Okay.
Does that make sense?
Yeah, and also like you're saying, now I'm understanding. Okay, I was kind of backwards. So even so down here by this divergent line on the bottom where that trench curves really big, there's also another orange one that's, relatively very large.
Uh-huh.
Yeah, right in here. There's one right there. There's like three right there that are relatively large. That one. So like you're saying, as it, I can't even know, as it goes underneath that plate and it's in that trench, those earthquakes that are occurring basically underneath that top plate are going to be the deepest. Is that what you're saying? Okay,
Yeah.
yes, I'm understanding now. Okay, I'm with you. And I think you're seeing that right, because those orange dots are much larger than even the green ones that have a higher magnitude that are just behind it. You know what I mean?
Yeah.
Okay, so
I don't know if this is making sense how I'm like saying it in the Google Doc, but I said just like as the dots get farther away from the trench, the depth of the earthquakes decreases, so they get closer to the surface. And then how do you explain those trends? The earthquakes are happening along a convergent plate boundary. So there's a subduction zone along that plate boundary, and it's going to have like the greatest depth.
makes sense to me. What would you expect to see if you did the same thing along the trench near Solomon Island? Okay, so the trench near Solomon Islands, or the Himalayan mountains, are they? Sorry. Oh my goodness, I'm so sorry. Are they different in any way than the Marianas Trench? Where's my book?
So I don't think it's different because like we have the Japan islands like right there. So I don't know why it'd be different along near some other islands. Guess we could look at them.
Oh no, the minions are back.
Orcs.
How old are your kids, Sergey?
6'4", 1.4 probably.
1.4?
Yeah, 1.5 probably. Just rounding.
Let's get exact now.
What?
Let's get exact.
Okay.
6 and 4 isn't too bad. They're starting to become independent. But
Yeah, like 1.5 for the little one, and then 6 for oldest girl,
yeah,
and middle one for.
4-year-old and 6-year-old, they start to become slightly independent. My 6-year-old is
Mm-hmm.
independent, and my 5-year-old is extremely independent. But 1.5, not so independent.
Yeah.
Oh. Okay, so where is the Solomon Islands and the Himalayan mountains? Oh wait, did somebody already answer those questions?
I just put well,
Well, because the
it
mountains
makes sense to
isn't
me
it?
that it'd be different at the mountains
Oh
than
yeah. Okay.
I don't know. But aren't the Himalayan mountains at a subduction zone as well?
I'm sorry, what?
Weren't the oh my gosh, I can't speak. Himalayan mountains, weren't they made by converging plate boundaries as well? But they just got pushed up instead of pushed down.
I have no idea.
Oh my.
My hand
So,
actually.
I
Solomon
love
Islands,
that. We
right?
need to make a song. Like primary song. Mountains go up and yeah. Um,
Sergey, can you just like search for the two
For
things? Can you
what?
see this Solemn Trench and the Himalayan mountains? We'll just do one at a time and see if it looks like the same thing. We'll compare it to the picture we have on the Google Doc.
TRE or TRA? Trench.
TRE.
Okay. Do we have anything?
yeah, collision between the Indian plate and erosion plate, which began. Hmm. It's a continental and continental.
Here?
Okay.
Solomon Sea.
Solomon Sea. Does it look the same?
Hmm. Somewhere here, yes. It's really deep.
It is really deep right there.
I have, yeah, divergent over here, actually.
Yeah.
1, 2, 3, 4. So, like,
And
making new layer. And we have, what is it again? Convergent lines here. Like both sides. I mean, like everywhere. It's interesting. How does it work together?
those dots all look pretty big.
Yeah.
I don't know because we're
Especially
zoomed in.
well,
So our area is over here, right?
yeah.
We need to compare with this stuff.
It
I don't
looks
know about you, but
similar.
those look much deeper.
What?
Those
They
earthquakes
look deeper.
on this one appear deeper.
Okay, let's go to the Himalayan mountains and see if it looks like completely different, and then maybe we'll know if they're supposed to look the same or not.
Oh, much deeper. Well, I can't see behind that, but yeah, 225 was.
I'm wondering if it's like right because it's right on top of that island.
It could be.
Whereas if you look at like Japan, it's like right next to, not necessarily like on top of.
But also, look how close together the okay, the yellow lines are convergent lines, right?
Mm-hmm.
Look how much closer together our convergent lines are in this area compared to where we were. Like you've got 1, 2, 3, basically 4. I mean, that's one line, but it angles at such an angle that you could consider it a fourth side. But you've got those really, really steep angles together of those convergent lines. I wonder if that has anything to play in with how deep the earthquakes are. Just that there's so much going on in such a tight space. Maybe does that make any sense?
Mm-hmm.
And then aren't the Himalayan mountains off of Australia somewhere? Right?
Maybe. Yes. Think so.
There you go. So would the difference here be the simple fact that it's just
They form a mountain range in
no
Asia.
convergent lines at all?
Huh?
There, I don't see like any divergent lines like close to that mountain range.
It's all convergent.
Well, and this is a continental. Would that be make a difference as well? The fact that it's just a continent plate and a continent plate that are.
We would expect them to be closer to the surface, right? Because there's not that subduction zone, so why would earthquakes be happening down here, whereas it's going like this? And so I feel like it'd be happening closer
Right.
to.
I mean, the closest earthquakes I'm seeing are like way out here. Are those areas that are white? Is that sand type areas? Yeah, this white, is this like sandy area? Huh. Let's see. Ainsley, when he gets really quiet and then he starts like showing us all these map things, do you feel like he's trying to teach us something in a silent manner that we're just not seeing? I get really self-conscious.
Yeah, I'm just like waiting for it to all click. I don't
So
know.
what,
I don't
oh
know
yeah,
what.
yeah, desert. Okay. Thank you, kind sir. I see sand. I see lots of sand. So I'm wondering, so if you see on this side, on the on the south side of the Himalayas, there's like no earthquake signs. I don't see any. But on the north side of them, there's some. But if we pay attention to the fact that there's water, so there's lakes, there's lots of sand, which is not as like a hard form of crust. I wonder if all of that plays into the fact of why there's earthquakes on that other continental side of the Himalayas. I mean, does that make any sense? Because you've got like soft land where it can move and it's probably eventually going to. Ooh, what is that blue line? Oh, see, he's silent and he's just like, oh, the blue line is transform. Over here, pay attention, lady, and then go back to the blue line, and then I'll zoom in and you can look at this, and then I'll zoom back out and give you another tour of the South Sea.
Yep. I don't know.
I think it's different simply because it's continental to continental, personally. Maybe
yeah, that's
maybe
just what I put.
that I'm missing, but there's just not a whole lot going on down here, and the land different type is so vast. I mean, like, it's very different.
I mean, do you guys agree with like what I put on the Google Doc?
And it's clearly as it meets together. It's not any nothing's going down. It's all going up.
Yeah.
The earthquakes would be a lot closer to the surface because two continental plates are coming together. Yes, I would say yes. Similar thing but deeper because two boundaries are closer together. And that's what I see there around those Solomon Islands is, like I said, yes, we have all those divergent lines just as we do, convergent lines just as we do around the Japan area. However, in the Japan area, they're not as compact in a smaller zone. So I feel like maybe that's causing a lot more like deep earthquakes to be happening around those Solomon Islands just by looking at it.
Yeah.
Okay, here he goes. Type away. Type away.
No, he's not moving.
Oh, no movement. Have we failed, kind sir? Oh no.
I'm sorry. My microphone was turned off, so.
What do you think, Sergey? Are we good?
Yeah, I think he's just.
I'm still. I still confused about this stuff. Earthquakes here, and some of them spread it over here. Why? Have no idea.
Well, okay, but these red lines right here are divergent. Which
here? This one?
What are these red lines right here?
Let me turn off and we can compare. So
I mean, they're like round circles. So is there literally going to be a hole in that? I don't know.
I don't know what does it mean either.
However,
how can I turn off all layers?
And figure out what it is.
Yeah, I'm just trying to. Yeah, so if I turn off the whole thing,
they're still
do
there.
I have? Yeah, it's something else.
Something different.
When I turn my places on, then we have plates here.
So So let's look at that really quickly though. But again, if we look at that, how many different convergent lines are so close together in that region where there are earthquakes up here?
Over here.
Yeah, I wonder if that
Where's my
plays
earthquakes? Okay.
a part in why that region has those earthquakes. Do you see what I'm saying?
Well,
I mean, there's so much going on right there in that little zone, and especially if those two continental plates are coming together, I wonder if the way the continental plates are really moving, if there's more movement of that bottom continental plate coming up in that zone and compacting all of those convergent zones, those convergent lines. Does that make any sense?
for me, I'm not sure.
Well, I just wonder if I wish I.
How can
I
I
wish.
turn out this stuff?
Isn't that the plate names? The plate boundaries?
It's just countries, probably. China. No?
So this is kind of my idea. I don't know how right it is.
Yeah, China over here, Mongolia,
Like
Kazakhstan.
a mountain forming, like right at that convergent plate boundary. Like it's already pushed this part of the Earth up, right?
Right.
And so if it's keep going together, it's got to push like the outside parts up too. So I'm wondering if this plate, like over here, is moving because it's trying to become part of the mountain. And so as that Earth moves, you get an earthquake.
Well, very much so. And likewise, at the same time, the plate that it's also moving into is mostly sand, desert. So I wonder if there's just if that area is so sandy that maybe there's just it like you said, it's becoming part of the mountain, so there's just more movement there.
Yeah.
Mm. I was thinking about like this. Yeah. Okay. Probably I see what you say about this part.
I mean,
Do you
because
see my mouse?
look how close that big desert area is, and the fact that even to the left of where those two continents meet, there's more desert over there. And so, to me, in my mind, it would mean that that ground
Yeah.
would maybe be more soft. And so, as that bottom continent is continually moving, maybe in that direction, yes, there is
Or
movement.
yeah. And so what about if we have like two different movements
Yeah, yeah,
meet each other in this corner? I
yeah,
mean transform and convergent, and
right,
they mix together over here. Okay,
right.
I got it. And
So,
then you said I'm sorry. You said this part of the land more soft comparing with not sure, not sure.
I
Okay,
think I think
just
it's
desert.
desert, but yeah, but
So
there's
it goes, it
just
kind
so
of
many
goes, huh?
there's just so many different things that could be causing or creating the situation to make what's happening. Because I mean, also look at over here towards the left of our screen. Look at how the land is actually uh, curving instead of no, it's bending. Um, over here on the
Here?
left, right
Oh,
here, yeah,
here?
right here along that blue line. See how it's kind of
Yeah.
almost turning into a wave right there? The land is actually almost turning
Yeah,
like
because they moves like in this way, right?
yeah, right. So, but then over here on the top, it's curving, but it's a straight line curve. So yeah, so there's so much movement going on that I would have to say that that's probably why there's more earthquakes in that little point because of the different types of movement. Just based on the different types of land and the different things that are happening.
Yeah, I agree.
What would be so fun is to take a sandbox and to be able, and they have actually, in fact, I've been part of my bibliography thing that we do every week. There are some science labs that have actually taken in and created these basically play sandboxes where they're being able to recreate what's going on with these continents and how they're moving and how they're, you know, how they meet in the different types of land and how that creates different shapes and changes and effects, and it's pretty interesting.
Cool.
It's called tectonophysics.
Yeah. Interesting.
Well, do you want to throw a screenshot of the Himalayan mountains maybe on there?
This portion?
Yeah. And then I think we're done.
I think we're good too.
Yeah, I will put it there. Sorry. I just want to make it thicker a little bit because I can't see anything in this stuff.
It's just so crazy how like the other part of the world is so different.
Yeah.
Like we're all on the same earth, but it's very different.
Right.
I just like think of people in like the olden days when they just knew their one little place and they thought that was like the whole earth, but how we know now. But it's so different.
So something like this?
Yep.
That's good.
Okay.
Do you ever wonder sometimes as we learn things about the earth and just anything, even about our own body, does it ever make you stop and think to yourself that God really does have a sense of humor, that he put these mysterious things out there to happen like this so that we would sit here on our couches at 10:30 in the morning and talk about why the sand and the mountains and this and that look like this? Like, have you ever stopped to think about how he has to have a sense of humor and a desire for us to be like little children that are building in the sandbox and rock, it's really shiny.
Always, right?
It's really shiny, you know. It
Yeah.
it brings, I don't know, it brings perspective as to one of the reasons why he wanted us to be here, why he wanted to give us this chance as for immortal life. It's interesting.
Yeah. I also think about how when like I'm learning things and stuff like that, how it's like on the smaller scale of everything. And so he's probably laughing and he's like, "Oh my goodness, this is so easy."
I know, right? If you could just fly up here and sit and watch this one, you know, the earth, the whole picture, if you could just see it all, you would get it. And you would stop thinking that it's a little sand hill, that this little water's making it float into the little sand hill. Like, I don't know. I It's been really interesting because I'm studying, you know, the creation a lot, like in depth studying the creation in a way that I have never had it brought to my attention. And then I study this geology stuff, and it makes me really stop and think about how we are here for a reason, and we weren't just, you know, made with no thought. Like, there was such deep thought put into everything that was made, every grain of sand and salt that was created. There was so much thought and desire and love, and and purpose for it, that it just has really brought great thought into my mind and my heart as to why I'm here.
That's awesome. Yeah.
I see you love geology.
I'm actually, you know, I'm really grateful that we have this school, because how can you get an education and believe in God, or even if you're not an LDS, even if you're not LDS, but believe in a higher power? I cannot imagine going to school and gaining a greater education and not being able to safely share my testimony in a stupid geology class. You know what I mean? Like, I having, this is my ninth semester since, well, including pathways. I cannot imagine not being able to share my thoughts on my creator and the spiritual things that have been brought to my mind through just a geology class. I can't imagine that.
It's really sad. I think it's really sad because kids who go to different schools and stuff like that, they're feeling like they are almost being like torn apart because all their professors are like atheist and only believe in science and stuff like that. And it's like, how do you get the same perspective as going to school where everybody believes the same thing?
Right. So it's been pretty eye-opening to finally be able to, excuse me, be able to not only gain an education, but to be able to basically meld it together with continuing to build on my testimony and continuing to build that relationship with my Father in heaven, and really starting to understand how and why things were done the way they were. Like the simple scripture, Adam fell that men might be, that men are, that they might have joy. That little scripture didn't have as much meaning to me even just 8 weeks ago as it does today. Like, there was no depth to it. It was simple. Well, Adam and Eve made the decision they made and did the things they did so that I could experience this life. Well, now it's so much more than that. It's so much more than that. It's so that I can look at this Google Earth document and go, you know what? Maybe this water moves this way and the earth is moving this way and it's causing these earthquakes, and that line causes this. I mean, that scripture has so much more meaning in so many different ways that, I mean, like I said, even 8 weeks ago, it didn't have the same meaning. It was simple that he did what he did and she did what she did so that I could be here. Now it's more than that. And I love being able to share that. It's just awesome.
Yeah.
And incorporate everything I learn to the gospel.
Yeah. It's amazing. We're blessed.
We are. Truly, we are. Well, guys, how does it look?
Have what?
How does it look?
Our work?
Yes. Well, your work.
No, I didn't write anything. I just.
You just included 4 awesome pictures. That's all.
Yeah. No, I think it looks good.
I think it does too.
Okay, I will send you the link to our video, and we are good.
Awesome. Yeah. Okay, well, thank you so much, guys. Enjoy your weekend.
Yeah, have a good Saturday and Sunday.
Yeah. Enjoy.
Bye.
See you later.